Before the invention of engines and electricity, we transported ourselves around on land using muscle power of humans, horses, and bullocks, a solar energy source derived from photosynthesis, which gives us biomass, the horses or our food, and oxygen. On water, we used the wind, again solar power, to push our boats across the oceans. In the 19th century, we started joining coal with oxygen to power the Industrial Revolution and started moving around on steamships and steam railways. In the 20th and now the 21st century, we found oil and gas that had been buried for millions of years and joined it with oxygen to provide energy for motor vehicles, ships and planes, and for generating electricity for trains and trams. This has the unfortunate consequence of releasing billions of tons of carbon dioxide every year into the atmosphere, resulting in climate change. In a future where we no longer rely on fossil fuels, we need to return to using solar energy or other replenishable energy sources such as tidal power and geothermal. Can you think of what solar-powered energy sources are available to us? Pause and think. The sun lifts water from the ocean, so hydropower is solar power. The sun heats the earth unevenly, causing winds to blow, giving us wind turbines and wave power. The sun's energy can be transferred directly to electricity using photovoltaic cells. And through photosynthesis, biomass and oxygen are generated, which we can rejoin when we use our own or animal muscle power, or when we use biofuels. In the future, it is likely that all transport, except aircraft, will use electric motors powered by a direct line, as in trains and trams, or by some sort of battery or fuel cell. The fuel of the future might be hydrogen, if we're able to store it efficiently. See our related video, Hydrogen and Fuel Cells. In this case, one of the two reactants is freely available from the air, oxygen. Otherwise, it will be a more standard battery where both reactants are stored together. The batteries need to be charged, needing electricity generated by non-fossil fuel means. The charging process regenerates the reactants in the batteries, which then react in the electrolytic cells, generating the electrical energy needed that drives the vehicle. In the case of hydrogen fuel, electricity will be needed to generate hydrogen from water, though we might one day find an efficient way of using sunlight to split water into hydrogen and oxygen directly. Aircraft need to be as light as possible, so they use oxygen from the atmosphere as one of the reactants, which they join with aviation fuel, such as kerosene, in their jet engines. Over 200 billion litres of fossil fuel are used annually, and it's not practical to replace this with so-called first-generation biofuels, those derived from food crops such as sugarcane or maize. There simply is not enough land for human crops and biofuels. For more, see our video on carbon neutral and biofuels. However, research on using algae to grow biofuels is underway. This would mean that flight would become solar-powered as photosynthesis traps carbon dioxide, making biomass, and releases oxygen. During the flight, the biomass, now converted to aviation spirit, rejoins with the oxygen, and the carbon dioxide returns to the atmosphere to start the cycle again.